The latecomer, slow walker, rocket, come along. So, we are back to the two mic solution, which has just reminded me that long ago when I was undergrad, there was a famous economics lecturer who was always very entertaining in class. And one time he put on a whole show, and he fell down on the ground and all kind of had a fit. And it took the class a long time to realize that he was actually having an epileptic fit, and they had to call the medics. I have two mics, it's 2 mic day, so if there's any kind of short and I get some kind of convulsions, please don't stop laughing for a moment to call an ambulance. We have to talk about static methods. This is exciting stuff. Brian, would you just close the blinds? Brian, close the blinds. Yes, you're Brian today. Close the blinds. Right, okay. What's your real name? Barry B. Barry Bryans. 4 of the 6 letters I got right. Or something like that. Now, we'll do a little work on arrays as well, 2-dimensional arrays, because that is going to take quite a while. Are you having a phone conversation? I saw you speaking into your mic. Say again? A voice note. Okay, right. Google. Oh, sorry. Right. So we still have to do a little bit of work on arrays, 2-dimensional arrays as well. I don't think me telling you is enough for you to get it, especially if you haven't read the textbook. And I'm still working on extra quizzes. Barry, Brian, what are you doing? Close the blind, not play with it, ever. Close it. It's not working, of course it's working. Candace, you pull the lever, and Barry just grab the bottom and pull. Grab the bottom of the blind and pull. Pull it. Yes, more. Pull. No, you want to play it. It's broken. There we go. Oh, yeah, pull. Harder. That's what she said. Right. So, arrays, we do a lot more arrays, but we have to do this stuff because you need it for the project. So by now you all know what static methods are. This is just a big picture. I cannot work without the big picture. I have to know where I'm heading and what's going on. We started with primitive time and assignment, that's all hand. We did math stuff. We've now done a little bit of I/O. So in last week's stat and tomorrow's stat, you'll see how to read things from the standard input, and we'll even do that today. Conditionals and loops we've done. Arrays we've kind of done. This stuff we're going to skip because we don't need it for the project straight away. And we'll first talk about functions and modules. I have to talk about static functions. But once we've done this, and we just loop back a little bit and do graphics and sounds, all the nice libraries that come with the textbook, we have basically covered all the stuff we need. And the rest of the course will just be more conceptual issues. I know it sounds vague, but you'll understand when we get to it. The second semester course is about object orientation, which is critical. I mean, you could say the whole point of Java is to have objects and manipulate objects. And we do that to a very limited extent, but the second semester course is really all about that. So what is a static function? Well, we know what a function is from school and from maths. I'm guessing you all have maths. It's something that maps a lot of input values to one output value. So it transforms inputs to output. And you know functions from school. You've seen cosine and sine and tangent. Those are the functions I always fall back on because everybody knows them. But now we are going to write our own functions. We could write cosine, we could write sine, but all kinds of functions we are going to write. So, let's just think about this. A Java function can take an argument, or 2 arguments, or 3 arguments, however many we want, but it can also take 0. It can be a function that doesn't take an argument. That sounds odd, because what is it going to output if it doesn't know what the inputs are? But you've encountered those kinds of functions all your life. The function pi is a 0 argument function. You don't have to give anything to pi, and pi gives you back the value of pi. So constants are, in mathematics, even things like 3 and 4, those are, you can think of them as 0 argument functions that give back a constant value. All constants are really functions. In Java, we are going to return 1 output value, although as soon as we learn how to write functions, we're going to break that rule. In fact, we've already broken it many, many times. You have already broken it many, many times. Why do we want functions? Well, in science, it helps with this kind of formula calculation. If you had to write out the code for square root that we've looked at in the past, you know, that little while loop that uses Newton-Raphson to calculate square root. If you had to write that out every single time you want to use square root, your programs are going to become humongous. If we don't have functions to make life easier, even in mathematics, it'll look horrible. So they're kind of shortcuts. Programmers, however, have another useful functions, and that is to, when you do something repeatedly, you don't want to write the code for that thing over and over and over and over. It just makes your program long and difficult to understand. So we are lazy. If we're going to do something over and over again, we write it once, we put it in a function, and we call the function to do that piece of code. We've seen built-in functions. We've seen math.random. We've seen math.abs. Integer.parseInt is a function that takes a string as an argument, arg0, any string, and sends back an integer. So that's a kind of function. It takes an input and gives an output. It here says our IO libraries, but we don't know about our IO libraries. We haven't looked at them. And we've written one function over and over and over, main. It's a function. It takes an argument. It takes a string array called args as its input. And it doesn't send anything back, but we'll learn about that shortly. So here we go. Here is our very first function. We're still going to write, if I can just highlight it clearly enough, public static. Apparently I can't. Come on, man. Oh, there we go. Okay, lick static. Public static. Okay? We're still going to write that little phrase in front, and in the second semester we'll learn what it means. In fact, we may start talking about it later on in this course. But for now, that's still a magic keyword we're going to write. Then we're going to write the return value of this function. What kind of thing do we expect it to send back to us? So in this case, we're saying that I want a function called square root, and it's going to send back a double. That's going to be its output value. Its output is going to be a double. And just like when I declare variables, I put the type, and then the name, square root, open parentheses. Oh, wow. I get all choked up about this, people. It's really emotional. Open parentheses, then a list of all its inputs, and a close parentheses and braces. And inside the braces, we indent. That means we push everything inwards a little bit with using tab or spaces so that we know, we can clearly see it's inside the braces of the square root function. And inside here, we can write whatever code we want. And in this case, we wrote exactly the code we wrote for the square root calculation before, except that if we look at the program we wrote last time, what did I call it? Okay, I didn't call it anything. Fine. Okay, I didn't write it in the class. I'm sorry. Last time, right at the end, we actually displayed the square root on the screen. But this time, we're going to use a new keyword that's part of a function called return. Return t says, now I'm at the end of the function, and the value I'm going to send back, the value I'm going to output, the value this function is going to give back to whoever used it is going to be t. So in this case, it'll be that 1.414. When Java executes the return statement, return some expression, it'll stop the function immediately. So if I put this right at the top, the function Java would hit the return and say, okay, now we're done. This function has returned the value. I'm going to stop executing all the other statements. This is a definition of square root. Let's see how we use it. Here is exactly the same definition as before. Here is our main function that we've written 1,000 times. What does it do? Oh, this is tricky. It declares a double array called A. So Java's going to make me a one-dimensional array called A that will store doubles. It says it's new double, so it's creating those boxes immediately. Args.length. Oh man, this is complicated. Args.length. What on earth is that? Well, args, we know, is the command line arguments, and it's an array of strings. Good? We understand that. And last week we learned that dot length gives me the size of an array. Dot length is the size of an array. So args.length is the size of the args array. If the user put 3 command line arguments, args.length will be 3. If they put 5 command line arguments, it'll be 5. However many arguments they give, this is the value of args.length. So now I'm making a new double array called A, which is the size of the number of command line arguments. And then I have a for loop that goes up to that number, and it says AI is double.parse double args I. So I take the ith command line argument, I give it to a function called double.parse double that we've seen before. It takes a string, args is a string array, args I is a string. It takes a string, converts it to a double, sends it back, because that's a function output, and it puts this value inside AI. This is tricky code, honestly. If you've programmed before, this is yeah, easy peasy stuff. I understand what's going on. But if you've never programmed before, this is quite a leap. But it's not that hard, is it? It's not that hard when I say it or ask you if it's hard. But you've never programmed before, Justin, have you? Are you following? Are you just saying that?
No.
Yes, he says yes. Okay. Okay. So now, after this for loop is executed, I'm in a situation where I have 2 arrays. One is called args. It's an array of strings. It's all the strings that appeared on the command line. Let's say there are 5 of them, but they're strings. Then I have a second array called A. It's the same size as args, because that's how I declared it, initialized it. It contains doubles. And for each of the strings on the command line, it contains the equivalent double value that I converted with double.parse double. And then I have another for loop that goes over this array A of doubles. And for each one, it calculates the square root by calling my own square root function that I've declared. I parse it AI, it's a double. So Java is going to invoke this function that I declared at the top here. It will send back a double, but it also takes one double input. It calls it C. Here I called it AI. Oh, here it's called C. And then it executes all this code with C. It sends back the answer, T. That answer comes back here, and I put it inside a variable called X, which is a double. which is in this scope, so it doesn't even exist outside the for loop. I print it on the screen. Who has any questions? I am teeming with questions. Yes.
You would be able to do this without the array, right?
Would I?
Just the string.
Just have one function, one input, one export, one output.
Well, let's think about that. That's not my question. It's a great question. We'll talk. We'll get to it. Yes. Where are you going first?
So I was going to ask what the public class needs and why do you have to say that line?
Why do I have to say that line? Well, I still have to write a program, and all my programs always start with public class something. So I am now going to steal this program from the slide and copy it and write something called newton.java. It's all spaces. I don't like it. Okay. Indent once. Here I'm inside the function. Indent once. Here is an if statement. Ooh, no indentation because it was compressed to fit on the slide. Here is a while loop. No indentation. Oh, bad student. Not going to pass this course. Okay. Here is a for loop. Must be indented. Okay. Thanks. So we're still starting with public class Newton because that's how we start all our Java programs. But now I define my own function called square root. In fact, I don't even want to call it square root. I want to call it squirt. I can call it whatever I want. And here I'm going to call squirt. Okay. We're not bound by any rules. We can call our programs whatever we want. We can call our functions whatever we want. We can call our variables whatever we want. Having said that, it's a particularly bad idea to choose imaginative names for all of your variables and functions and programs. I can go through all the variables, but if I did that, you won't know what this program does. That would make me a bad, evil person, in line with who were undisputably bad, evil people. Hitler. The more I hear about him, the less I like him. Let's say Genghis Khan, who killed millions. I'm killing millions of little brain cells because whoever is going to read this they're going to have a little stroke. Their heart is going to break a little bit because they won't know what the hell is going on. There are hedgehogs and squirts and all kinds of stuff. So this is probably a bad idea. Is calling it a good idea? Well, it kind of refers to arg, so that's fine. Is calling this variable I, yeah, I for iterator, it's going to iterate over it's going to repeat over the array. And I and j are common names for these kinds of variables. X, probably not a fantastic name. Squirt, probably particularly bad. Let's fix it. Squirt. Especially if it's a function name. It's a good idea to give it a nice descriptive name. If it's a variable inside, like t or then shorter names are acceptable. But personally, I still like giving it nice descriptive names. So this would be value. Is tolerance, but error I'm allowing, yeah, I guess. T is really the answer, so I think I'll call it answer. See, but now this line gets so long. I can live with that. And let's call X root. Okay, now anybody can read the program and understand what I've done. Have I made a mistake?
No, I
Oh.
just want to ask a question.
Yes, ask the question.
So in the first half, we get answer.
Yes.
And then we use that in the second half, in the second part.
Absolutely.
Right.
So this is a function that we don't need the second half. This is a function we can write and understand all on its own. It's called square root. It takes one input called value. Inside it manipulates value all at once, and it stores the eventual answer in answer. And this return answer will send back the value of answer. So here, I'm invoking square root by giving it this input and taking its return value and storing it inside a variable called root.
Okay, so do we necessarily use answer in the second part? Because we've written it afterwards. Because we don't mention answer in the second part.
Yes, answer only exists inside function square root. So answer is declared here, this variable, double answer. Its scope is the braces of square root. And when this terminates, when I send back the answer and the function terminates, answer disappears. It no longer exists. You ask such a brilliant question that we will talk the rest of this class about your question. But first, let's hear what Rivaldo wanted to know.
So I just wanted to know what does void stand for? So
That was my burning question. What the hell is this void? This is another function, clearly. It starts with the public static magic keywords. It's called main. It takes an input, which is an array, but it sends back void. We've never heard of void. So void is a pseudo type in Java, and it just means that this is a function that is not going to send back anything. It's not going to return. Void means, what does void mean in English?
Empty. The amount of friends.
No, it doesn't mean the number of friends you have. That's zero. No, it's not. Of course not. No. Void just means an empty space, which is a strange word. But so this function has no return type. It's not going to return anything. It would be a mistake for it to return anything. So if I were to write, let's just for fun, send back a value at the end. 10. Let's compile. Compiling. Java complains that incompatible types, unexpected return value when you set return 10. Not allowed to do that.
So all that when you return is the string something like that.
Okay, let's change it to, well, let's change it to string. So main is promising to send back a string. It's not. It's sending back an int. It's not sending back a, hang on. Incompatible types. Int cannot be converted to a string. I said main would send back a string, but it's sending back an int. Bad main. Okay, right. Now we put double quotes around the 10, and it becomes the string that contains the characters 1 and 0. And if I now compile, Java's happy, it compiles. Will it execute? No. For your program to execute, you should have a void main, not just a main function. Main method must return a value of type void in class Newton. Please define the main method as, and it tells me what to do. Okay, that's fine. I'll do that. There is one thing I can write here. I can just write the return. If this is a void function, and I want to stop it, I want to send back a value, which will be nothing, I can say return at any point, and it'll do that.
So you can have that like an exit.
Say again?
You can use return just as like an exit.
Maybe. Yes. Yes, kind of. Not always. Okay, and now I'm just going to put a value, And Java, this program calculates the square roots. Let's just take a few we know. 81, 4. So it calculates 7 and 9 and 2 square roots. It's an approximation thing. If I make my tolerance less, it will be more accurate. Ugly duckly. Right. Let's fool around with, say your name again?
Sumaya.
I've never heard it. Sumaya.
Yeah, it's the first time sitting in front.
Okay, excellent. Good. Yeah. Maybe we should have a little rule that if you've sat in front before, you're not allowed to ever sit in front again. To cycle through the class to get new people's names to the front.
But how can I live if I'm not here? And some people sit in front.
Well, you are not near me. You are in the third row. You still have 2 rows to go before you're in the front row.
Can I sit in the third row indefinitely?
Yes, but not in the front row indefinitely. Only one visit to the front row.
It's not indefinitely if we leave like the last.
The only issue of this brilliant plan is that it means that the people in the front row now will have to move back. But the back people chose the back because they don't want human contact. And they're not going to come to the front. So the front row and the second row and the third row will grow empty. You'll all be at the back. I'll be here at the front. So let's call the whole thing off.
Awesome.
Sumaya has some brilliant ideas. Why is an answer used here? So let's look at a little question that I'm going to call don't be ridiculous. Everybody happy? Stop me when I do something that freaks you out. If I give you the definition of mystery, are you all happy to tell me what this program will print?
Yes.
Okay, good. Let's write down the definition of mystery. It's going to send back an int. Its name is mystery. It takes 3 arguments, and they're all ints, so I'll write that down. Int b. Sumaya, what will mystery print? I like that. I like that. You didn't waste any time on thinking about it. Instinctively, you looked at it and said, no ways. I am not going to figure this out. It's better for me to stop right here. Let's take a few bets. Brian, Jerry, whatever your name is. Blindy. What is exam 01 program going to print? Okay, hang on. I'll make it a little tougher. Oh. Firstly, let's see if it compiles. Maybe I've made a terrible mistake. Or maybe the answer is, it doesn't compile, Yaku. Ah, it compiles, damn. So it's going to print something. What is it going to be? This is the kind of question I love because students get so confused and they just go crazy. You can see them freaking out in the class, in the tests. We've had many students pass out during exams. To the extent that we now have a nurse on standby to help the students. And, they get attacked, they get fits, convulsions.
We handle projects like this that have variables like
And
this.
all in one line.
Yeah.
Yeah. Lose marks. Easy enough to write 0.
Can I rate you a guess?
No, maybe.
Minus 28.
Minus 28. And for B, I don't know. Okay.
Can I ask like this?
Yes. Minus 28 is one answer, yes.
In the function, right? The mystery function.
Mystery, yes.
We use D, but before D is defined.
We use D before D is defined.
We define D by mystery.
Do we?
Yes. To define D, we have to use mystery. But
Do
to
I?
use mystery, we have to use D.
Whoa. Deep, man! Man, that's deep! Okay. Ah. Give me a second. I didn't spend 4 years at art school for nothing. Okay, right. Let's get this sucker off the ground. Right. I've drawn the boxes in the comments, but you know that they don't exist until I declare the variable. So really, it's illegal what I've done. Never mind that. I say Java, and this is main, so it's going to execute first. Make a variable called a int and store 20 inside. Java goes 20, got it. Make a variable called b and store 10 inside. Got it. Make a variable called c and store 17 inside. Got it. And now make a variable called d and store inside. But first we have to calculate prop. So it's an invocation of a function. Function is going to take some arguments and it's going to send back a value. That's what a function does. Takes input, sends back an output. So let's see what I pass to mystery. I mean, if I call sine 30 degrees, sine is going to work with that 30 degrees. So what am I passing to mystery? Well, I'm passing b, which is 10, then a, which is 20, and then c plus 1, which is 18. Is that correct? Those are 3 values I'm passing to mystery. And mystery has its own problems. Now it started running. Mystery takes 3 inputs. It calls them C, B, and D. And when I pass it 10, 20, 18, it takes those arguments and puts it inside boxes called C, B, and D. C, which will get the 10, it's the first argument, and I passed 10 as the first argument. So the 10 goes in C, then B gets the value 20. And D gets the value 18. Then mystery says, declare a new variable called A and put inside B plus D. 38. Okay. So the A, B, C, D inside mystery has nothing to do with the A, B, C, and D inside main. The scope of these variables, they're only alive, they're only visible to main inside these braces. Inside those braces, when I say A, it's this A with the 20 inside that I'm talking about. If I say B, it's this B with the 10 that I'm talking about. Whenever I talk about A, B, C, D inside here, it's these variables, these boxes that I'm talking about. Mystery, though, is its own function. It has its own A, B, C, D. Their scope are the braces of mystery. So inside mystery, if I talk about A, it's this A. If I talk about B, it's this B. And so when I say B becomes 77, It's this B that mystery will update. And the B inside main stays unchanged. Mystery is made to work independent of main, or whoever else call it. It's just a function that takes inputs and calculates the output. It doesn't depend on the fact that whoever called it has a B, C, and D and all that. Then mystery says, I'm going to send back C minus A, which is 10 minus 38. So that's equal to minus 28. So this eventually sends back minus 28. That's what I put inside D. That's what I print here. And then I print B. And this B, oops, this B refers to the 10B. So I print a 10. Is everybody happy? Is it a big mystery? Well,
Your variable names are confusing, and then you switch the orders, which is mean.
well, I've pushed things to the extreme a little bit to test where your knowledge ends. But I know that you are all able to handle this. So I will present a next program. Oh, well, let's run it just to see if we're right. Oh, yeah. Oh, yeah, fine. Excellent. Right, next, let's try another one. Let's keep things simple.
Why not do that in one method? Honestly.
Yeah. Why not do it in one method? Of course I can do it in one method. And it'll be straightforward. I mean, it's a big mystery now, but that's exactly what the name of this game is. I'm trying to test if you can look at an extremely simple piece of Java code and follow what's going on, and if you understand how Java treats parameters and treats local variables and treats function invocations. So when I write a function like this, when I use it, I say that I invoke it, or I call it. It's called a function call or a function invocation. The function is not alive until I call it, and then it suddenly starts executing. Yes?
With regards to
Robert? Robert? You look like a Robert. David Roberts. Yes. David Roberts. Let's Mr. Roberts speak.
with regards to the function, when it says int A and int C, does it specify that those inputs need to be an int, or does it convert the variable A into an int?
Oh, good question. Let's just see if this compiles quickly, David. I made a mistake here. You're very right. Call it. There we go. Okay, it compiles. Okay, let's try David's idea. If we send Enigma something that's not an int, what will it do? 1.2 is not an int. That's a double. Ah, not happy. Incompatible types. Possible lossy conversion from double to int. It's not happy about that. Let's see if it's okay to give it a string. No. String cannot be converted to int. Not happy about that either. Well, let's stick to an int for now. And in a sec, we'll have one more question that stretches our abilities. But first, David, what is this program going to print?
You run it with C. You know,
What do you want?
you run it, yeah, just run it.
Yeah, I know, but this is the exam. We're in a test now. You don't have the luxury of running Java programs. So I'm asking you to demonstrate that you understand how it works. So let's see. A is 99, B is 33, that's fine. C is conundrum of A plus B. Oh man, you have to add. But that's 134, means 134. But I've added 2 too many, so let's make it 132. Sending that to conundrum. So its A is 132. B will be 264. Then I pass 264 and 132 to Enigma, which calls them A and C. B becomes 3 times C, which is 396. Subtract 1 is 395. So C contains 395. I'd better keep a record of this because 395. Sum. Oh man, I don't know. Yes, 659. So that's going to come back and sit in C. 659. A becomes 20. Now I'm calling Enigma 1, 2. So B will be 6. 6 minus 1 is 5. So I'm adding 5 to C. And that's what I expect you to print. Do you agree, David?
Yeah.
You fool.
No, that will 80 and 20 then.
You should never trust my arithmetic. It's always way off. Compile. Yes. Execute. No. Oh, lucky guess. Okay, right. Okay, fine.
I had faith.
Say again?
I had faith.
High five. Yes, exactly. In the exam, I won't give you numbers that are this complicated because I'll work it out myself and find that it's impossible, and I know you can't do arithmetic. I wanted to do one more, so I'll just be very quick about it. Exam 03.java. Let's just keep Enigma. And let's say that A is Enigma of 1 and Enigma of 2 and oh, no, not Enigma. That can't be ridiculous. Yes? No, sorry, I thought you were helping me out. That's fine, yes. Why? Why what?
Why do you ask for A in so parts but you're not using it in the method?
Maybe I haven't completed the method. Maybe this is just my first draft, but in the future I'm going to use A in a very spectacular way, or maybe I'm about to ask a question about do I really need A in this function, or all kinds of reasons. I'm a crazy guy. Crazy. Right. David, who sits next to you? Chase. Oh no, Chase has lost his hat. Chase, what is this program going to print? Quick. Let's see. A becomes an integer variable. We store in it puzzle of 1 and this value. But first we need to calculate this value. To calculate this value, I need to calculate puzzle of 2 and this value. So first I need to calculate this value. So this value will be the puzzle of 3 and 4. Invoke puzzle. B becomes C, which is the 4, times 3, which is 12 minus 1 is 11. So this is really puzzle of 2, 11. So what's the value of 2, 11? Well, if I pass 2 and 11 in here, B will be 33 minus 1 is 32. So this is really the puzzle of 1 and 32. And what is the puzzle of 1 and 32? Well, B will become 32 times 3, which is 96, minus 1 is 95. So this is really 95, and I put that in A, and I print it. Do I? And it prints 95. Happy, David? Happy, Chase? Okay, excellent. Very quick Afrikaans summary because I must do this, and it's good for us to hear it again in different language. As ek kyk na statiese funksies, ek wou eintlik gepraat het oor tweedimensionele skikkings ook, en ek sal beslis Woensdag nog daar gesels. Maar hierdie statiese funksies is nie regtig iets niets nie. Ons het nog die hele tyd een funksie geskryf na my. Behalwe nou kan ons eie funksie skryf wat verskillende waardes terugstuur. Ons sal Woensdag kyk na hoe hulle skikkings terugstuur. En ons het 'n bietjie gekyk na raaisels oor wat die tipe vrae wat ek al in die verlede en in die toekoms in toetse vra. Iemand het vir my, somebody sent me a message asking what is going to be in the test. And I'll put the details on the Sunderland website for everyone to see, right? But we're not going to have static functions in the test. So only everything up to arrays. I'll put, are you going to draw shapes? Maybe. Maybe not. If you do, it won't be the trivial kind of shapes you had in the test, in the tuts. It'll be something a little more advanced, because I know many people told me afterwards that the tut was an insult, how easy it was. They were offended. Hang on, guys. Yes, David? No, maybe a little bit, but you can see Thursday tutorial, can't you? Plus, the solution won't be published until next week, so you won't. I don't think people who do the Tuesday tutorials will have a particular disadvantage. Do they? I've never seen anyone practice in a tutorial.
I practice the tutorial. I see what's.
I'm so sorry, our time is up. I'll see you next week.